Continuing from where we left off, the probability of B given A is 4 out of 6 because we've reduced our sample space by 1 by drawing the red marble. So we've gone from 7 to 6 marbles total, and from 5 red marbles to 4 red marbles. So 4 out of 6 reduces to 2 out of 3. We're going to multiply the probability of A by the probability of B given that A has already happened. 5 over 7 times 2 over 3 gives us 10 over 21. A red marble is drawn from a bag of 2 blue and 5 red marbles and then replaced. Then a red marble is drawn again. Keyword here, replaced. So that makes these independent. We put it back. We're not changing the sample space. So the probability of A is again 5 out of 7. The probability of B, since the sample space doesn't change, is 5 out of 7. We multiply these together and we get 25 out of 49. And that's the end of our first page of notes. So let's go to the next one. What we've been looking at for B given A is conditional probability. That's used to find the probability of dependent events. It can also be used when additional information is known about an event. So one way of looking at that is this. This is something that we do in statistics sometimes when we have extra information about a scenario. So you can do this when you know what our first event is, but you can also do this when a problem gives you some extra information. So you see this big problem, cross it out. We're not going to do anything with that. But look at this exercise. It tells us that a blue marble is selected at random from a bag that originally held 3 red and 9 blue marbles, and it is not put back. So then we want to know what's the probability that a second marble selected will be blue. So we want to know what are our possible outcomes after that first marble has been selected. Well, originally there were 3 plus 9, which would be 12, but now there's only 11 left. And our favorable outcomes, originally there were 9, but if the first one was blue, there are only 8 blue marbles left. So our probability that the second one will be blue is 8 over 11. Pretty simple. We're just looking to see what information we've been given about what has already happened, our condition, and then we're finding the probability based on that condition. Let's look at our other exercise. A die is rolled. If the number rolled is less than 5, what is the probability that it is the number 2? So we know that it is less than 5, so that eliminates some of our outcomes. So on a die, the numbers that aren't less than 5 are 5 and 6, which leaves 1, 2, 3, and 4. 4 possible outcomes. And of those possible outcomes, the favorable outcomes are only 1. Only one of those numbers is the number 2. So that means that our probability is 1 out of 4. And flip to the back for our last 2 exercises. This one's interesting. A quadrilateral has a perimeter of 16 and all side lengths are even integers. That means that they are whole numbers that are evenly divisible by 2. We want to know what is the probability that the quadrilateral is a square. So I did most of the heavy lifting for you. Here are the possible outcomes that fit even integers that add up to 16 for quadrilateral perimeter. So here are 4. There are 4 possible outcomes that fit for quadrilateral perimeter side lengths or even integers. So which of these are favorable outcomes so that the quadrilateral would be a square? There's only one because a square has to have all sides equal. So the probability would be 1 out of 4. And our last one, a spinner with 8 evenly sized sections, numbered 1 through 8, is spun. Find the probability that the number spun is 6, given that it is an even number. So possible outcomes are evens. So there's 8 sections, but only half of them are evens. So that leaves us 4 sections that could possibly be our outcome. And our favorable outcomes are only 1 because we're trying to see if it's going to be 6. So our probability that it's going to be 6 is 1 out of 4. And that's it for lesson 3. Your homework is the last page of your packet, excluding the extra credit. Please let me know if you have any questions, and I will see you next time.